All right, so how do you convert to r to the power of 2 cos? Wait, sorry, this should be not like this. um, there should be cos here. There you go. All right, so r squared times cos 2 theta equal 1 into Cartesian form. Okay, so we have to remember our double angle identities here. So we know that cos of 2 theta equals cos squared theta minus sine squared theta, okay? So we'll have to use this double angle identity to solve this problem, right? So r squared cos 2 theta can be written as r squared times cos squared theta minus sine squared theta, okay, equals 1, okay? We're going to expand this. This equals r squared cos squared theta minus r squared sine squared theta. Okay, cool. And we can alternatively write this r squared cos squared as r cos theta minus, it should be squared, minus r sine theta squared. All right, cool. Now we're going to need to talk about Cartesian form and polar form, right? So currently this equation is written in polar coordinates, all right? So we had, I guess, 2 different coordinate systems. So this is our Cartesian, and this is our polar. So the polar coordinates uses the magnitude of the hypotenuse and the angle as coordinates, and the Cartesian uses x and y coordinates to graph onto the plane, I guess, or to graph onto our axes, right? So the conversion between Cartesian to polar is, so we have to calculate r, and r is the square root of x squared plus y squared, and our theta value, our angle, is the inverse of tan of y over x, okay? So these 2 equations or formulas will help convert our x and y coordinates into our polar coordinates of r theta, okay? So if we're going backwards, back to Cartesian coordinates, we have to know that x equals r cos theta and y equals r sine theta, okay? And these 2 equations will convert our r and thetas back into its xy coordinates. So x and y are our Cartesian plane, okay? So I shouldn't have drawn it right in front of my solution here. Maybe I can move it somewhere else. Okay, try moving this back down here. Okay. And I'll rewrite it later. But okay, so we have our equations here: x equals r cos theta and y equals r sine theta, right? Here we have r cos theta, right? So we can say that that equals x squared, and we have r sine theta as y, so y minus y squared. So now we have converted r squared cos 2 theta back into its polar or Cartesian form, which is x squared minus y squared. So this equals to 1, and now we have x squared minus 1 y squared equals 1 is the Cartesian form. Okay, so we have converted our polar coordinates back into Cartesian or rectangular coordinates, I guess you can say. So the junior tutor also used the solution that I used. They used a double angle identity to transform this equation, and then they expanded, and then they realized, oh, this equals to x and this equals to y, so we'll just sub it back in, and we get our derived equation. So cool. All right.